Alright, so what we're doing is we're continuing the video with a circuit that we're going to work, which is an RL parallel circuit. So what I have up here may look a little weird, okay? Because I don't have everything connected up. But I broke it up to hopefully clarify how you actually solve these individual components. The resistors, the inductors, and the capacitors. And then what we're going to do is we're going to find Z first, and then once we find Z, we'll assign a voltage, and then we'll work the rest of the circuit, and then we'll check ourselves, okay? So I'm hoping that this will kind of clarify some issues in the past of how you add components in parallel. Alright, so this circuit, what we have, or what we're ultimately going to have, is a circuit with 2 resistors, 2 inductors, and 1 capacitor. Okay? So what we got to do is we need to find these individual totals before we can find Z. So remember from earlier, my Z formula is going to be Z is equal to 1 divided by the square root of 1 over R squared plus parentheses 1 over XL minus 1 over XC and squared. Okay? So in order to do this formula, first we must find our individual totals to plug in to the Z formula. Okay? So let's look at it broken down. I have 2 resistors that are in parallel with each other. So what I'm going to do is I'm going to go ahead and connect these. So now I have an RLC parallel circuit. So what I want to do is I want to break each one down and solve it individually. So what I'm going to do first is look at my 2 resistors. Okay, I have 2 resistors that are in parallel with each other. So what I need to do is I need to find a total resistance. And to do that, I'm going to have resistance total is equal to 1 divided by 1 over R1, which is 400, plus 1 over 200, which is R2. And doing that will give me a total resistance. And then that will go right here. So in your calculators, so if you have the TI-30XA, you have a 1 over button, which is really handy. And if you have anything more advanced, the TI-83 up, it is going to be an X little -1 out to the side. That is your, what we call the 1 over or the reciprocal button. So first, to key this in, we're going to do 400, 1 over, plus 200, 1 over, hit equals, and then 1 over that. And what you see is total resistance should be 133.33 ohms. Alright, so that is the total resistance of these 2 resistors parallel with each other. Now look at what we have next. We have 2 inductors that are in parallel with each other, with an inductive reactance of 600 ohms each. So now, what we want to do is we want to take and do XL total is equal to 1 divided by 1 over 600, which is XL1, plus 1 over 600, which is XL2. And that's going to give us our total inductive reactance. So in your Z formula, that number will go here. Okay? So we have 600 1 over plus 600 1 over, hit your equals button, and then 1 over that answer. You should get 300 ohms. So that has 300 ohms for inductive reactance total. Now, capacitive reactance is really easy. There is only one of them. So if there's only one of them, there's nothing to parallel that with yet. So capacitive reactance total is just this lone 200 ohms. All right, so now that I have a resistance total, an inductive reactance total, and a capacitive reactance total, now I can use that information and plug it in to the Z formula. Okay? So, let's go ahead and rewrite the Z formula with this information in there. So, I have 1 divided by the square root of 1 over r squared. So, that's going to be 1 divided by 133.33 squared plus parentheses XL 1 divided by XL minus 1 divided by XC. So that's going to be 1 divided by 300 minus 1 divided by 200 and then squared. So that's what my formula actually looks like. So again, break it down, get a resistance total, get an inductive reactance total, and get a capacitive reactance total. And then once you have these, then you can plug it into the Z formula. Okay? So now, this is a little bit of a challenge to put into the calculator. Okay? So, what we're going to do is follow me step by step. So, if you have the TI-83 or up, this is not really going to help you guys. Really, all you got to do is put it in exactly how it looks. So, you can key in 1 divided by, put a set of parentheses, and then type all of this in. Square root of 1 over 133.33 squared plus parentheses this squared, hit equals, and you got it. Okay? And if you have any questions, I actually don't have a TI-83, but if you have questions about that, feel free to chat into the team chat, and I can walk you through it. But for now, I'm going to show you on the TI-83 because I think a lot of people have this, since this is the one we recommended at the beginning of the semester. So, to find Z, I'm going to start out, I'm going to do 133.33 1 over squared. Okay? So again, that was 133.33 1 over squared. Plus, parentheses, 300 1 over minus 200 1 over, close the parentheses, squared. Then you're going to hit equals, square root it, and then lastly 1 over it. What you should get for Z is 130.16 ohms. So, we're going to go back through that again, okay? So, in the calculator, in the TI-30XA, you're going to key it just like I'm about to say. 133.33 1 over squared plus, open a set of parentheses, 300 1 over minus 200 1 over, close your parentheses, squared, hit your equals button, take the square root, and then do your final 1 over. So basically you're starting and you're working inside the square root box, equaling that out, then square rooting it, and then doing your final 1 over. So again, you're working it inside out, so bottom to top, okay? So practice that a few times, okay? So I'm going to give you just a few moments, so if you want to hit the pause button right now, and practice this until you get this number, and then once you do that, proceed. So what I'm going to do is I'm going to stop the video, and then we're going to pick back up with everything up here with Z and then a voltage total to go along with it. Okay? So go ahead and practice this until you get it, and I will be right back.